Hello everyone, this is Dr. Sulaiman Khan and you are watching my YouTube channel The Beauty of Mathematics. In today's lecture I will talk about the bisection method. Bisection method. In numerical analysis, bisection method is one of the fundamental methods for finding the roots of the equation of the form f of x is equal to 0. So to prove this method properly, we will suppose that a function f belongs to is a function f is continuous in the interval ab, and it also satisfied certain condition that the values of the function on a and b both are their multiplication is less than 0. It means that f of a and f of b have some different sign, so then by using the intermediate value theorem, there lies a point p belongs to the interval ab on which the value of the function should be equal to 0. So what we will do here by using the bisection method, we will try to find this root p. And what is the main process in this method is we will find the value of the function on a and b, and we will proceed and we'll check the value next on the middle of the interval, which is a plus b divided by 2, and we will check that in which place this condition is satisfied, and we will proceed it for the next iteration. So to begin the proper method, we will start the first iteration. For example, to begin, we will set a1 is equal to a. This value, for example, is equal to a1, and b1 is equal to b, and let p1 be the midpoint of the interval ab, be the midpoint of the interval ab, that is p1 is equal to a1 plus b1 divided by 2, because we have taken a is equal to a1 and b is equal to b1, so this is the middle point, which is a1 b1 by 2, and we take it as b1. So what we will do in this method is we will check the value of this p1, and we will put these values in f of p1 is equal to 0, so it means that this is the required root of the equation. Then p is equal to p1, and we have find the root, and we have done the required solution we have find out. So we are done if we got this condition. The middle point what we have find from a and b interval, which is a1 b1 divided by 2, and if we put that value in the function and we got 0, so this is it means that P1 is the root, which is the required root we are searching for the solution of this function. So if this is not the case, then how we will proceed if of P1 is not equal to 0, in this case, like in the above case, then how we can proceed? Then it means that f of P1 has the same sign. This will have the same the sign of a f of a or f of b. So we will check it that what is the required condition. Then f of P1 has the same sign is either f of a1 or f of b1. So if f of p1 and f of a1, p1 which is the middle value we have find out here, if f of p1 and f of a1 have the same sign, so then it means that the required root belongs to the interval. Which one? If this and this has the same sign on this point and this point, so it means that the root will be in the opposite sign, the interval which contains opposite signs. So it means the P belongs to P1 and B1. So in this case, for the next iteration, we will set A2 equal to P1 and B2 equal to B1. This will be the next iteration. If this is the case, if of P1 and if of A1 have the same sign, then we will proceed like this. And if this is not the case, if of P1 and f of a1 have the opposite signs, then it means that P belongs to the interval a1 and P1. So in this case, we will set A2 equal to A1 and B2 equal to P1. So this will be the case, B2 equal to P1. So this is the main method, and we will repeat the same procedure for the second iteration. Then repeat the above process for A2, B2. What interval we have got, so we will proceed the same for another interval, and we will continue it for the second iteration, for the third iteration, for the fourth iteration, and so on. Now we will explain the bisection method geometrically. For example, this is the interval A and B, and we have named it A1 and B1, and the value of the function on A is this, which is an f of A or f of A1, and this is the function value f of B1. And in first iteration, what we done, we have found out the middle point of this A1 B1, which is P1 in the theory as we have discussed. So on finding the value of the function on P1, it's a positive number, while f of B is also a positive greater than 0. So and the value of the function on the point A or A1 is negative. So this f of A1 and f of B1, this both have this different sign. So the interval of discussion would be A1 and P1. So for the next iteration, we will consider A1 P1, and we will find out the values, the middle point of A1 P1, which is equal to P2, and we have again find out the values of the function on P2, which is also negative. So when this P2 is negative and P1 is positive, so it means the root lies in the interval P2 and P1. So in the third iteration, we have taken the interval P2 and B2. So the roots lies over here, and in the third iteration we will divide this P2 and B2 in the middle, which is P3, and we will check it again while putting the value of P3 in the function and approximating its value whether it is positive or negative. So by the same procedure we can continue for the third iteration, fourth iteration, and fifth iteration, whatever is required. So this is all about the bisection method. Thank you so much.